This video is the back side of worksheet 12-2. Alright, I've already changed all the degrees Celsius to kelvins, and so now I just need to identify my pressures, my volumes, and my temperatures. M3 means cubic meter, and that's a volume. Kelvin is temperature. Here's a temperature. kPa is pressure. kPa is pressure. I've got 5 numbers involved, and so I'm going to use the combined gas law. So that means I'm going to have a total of 6 numbers, and I just have to put everything in their right place. So it says a gas storage tank has a volume of 2.9 times 10 to the 5th when the temperature is 301 and the pressure is 101. So I'm going to put 101 here. I'm going to put 2.9 double E5 there, and I'm going to put 301 there. Alright, that just means that the other numbers must belong in this area. Okay, this temperature is 258, this pressure is 93, and it's asking for the new volume, so there's our unknown. Number 7. Oh, by the way, if you don't remember how to punch this in, you go 2.9, and then there's a double E button, and then a 5. So you're still cross multiplying, and there's really nothing different about this. If your answer is huge, you're always welcome to put it in scientific notation. Alright, number 7. Liters is volume, kPa is pressure. We've already got a temperature there. We've got a temperature there. It says, what will the volume be if the temperature is increased and the pressure remains constant? So they're giving us 100, but really we don't even need that because it says the pressure remains constant. We could use the combined gas law, but it's really not necessarily because the pressure would be here, would be constant, and so there's really no need to do it. So we're going to put volume over temperature equals volume over temperature. So 0.76, and its temperature at that one was 294, and the other volume is our unknown, and the other temperature was 333. Number 8. kPa is pressure. We've already got our Kelvin, so that's temperature and temperature. So the formula you would use would be P over T equals P over T. Alright, these are, if you read the sentence, a rigid container of nitrogen has a pressure of this at the temperature of this. So 343.1 over 654, and the other temperature is 273. Number 9. A gas is warmed, it's got this volume. Originally it occupied this volume. This is actually our V1, and this is our V2. Right, originally it occupied a volume of 11 liters at this temperature. So that means 11 is here and 344 is here. Our unknown is what is the temperature, and 21 goes there. Oops. Well, okay, skip that. We'll do it over here. So this would be V1, V2, T2, V1, T1. And the last one. I went ahead and changed milliliters to liters because it's a good practice to get into. Because when you use the ideal gas law, you have to have liters if you're going to use 8.31 as your constant. So If you didn't, it'd be okay, but it's better to change things to liters. Alright, so liters is volume, Kelvin is temperature, liters is volume. So the formula would be V over T, V over T. Alright, so when you actually read it, it says the gas inside of piston was heated until the volume increased from 129 to 950. So this is actually V1 and this is V2. So I'm going to go ahead and put 0.95 liters there and 0.129 liters there. If the temperature was originally, so this is our T1, so 291, and then our unknown is Kelvin. Now it wants us to change it back to degrees Celsius. So after you get this, you minus 273 from it, and that'll equal degrees Celsius.